Good evening, ma'am.
Good evening, ma'am.
So last class we have seen quasi-integral formula for the derivatives and other things. So we already have seen how to calculate residues at each of the poles, the simple pole or the poles of higher order is we have already seen. Now what we are going to see in this classes, we are going to see about quasi-residue theorem. Okay, we are going to talk about quasi-residue theorem. 1 minute, it's not working. Yeah. Quasi-residue theorem. So what does this quasi-residue theorem says is, you can take down, if f of z is analytic, if f of z is analytic at all points, if f of z is analytic at all points inside and on a simple closed contour C, inside and on a simple closed contour C, simple closed contour C, except at finite number of poles, except at finite number of poles, say z1, z2, z1, z2, etc., zn, z1, z2, etc., zn within C, then integral over C f of z dz is equals to 2 pi I into sum of the residues at z1, z2, etc., zn. Integral over C f of z dz is equals to 2 pi I into sum of the residues of the function f of z, sum of residues of f of z, you write down, of f of z at z1, z2, etc., zn. So what does the quasi-residue theorem says? The given function f of z is analytic, okay, inside and on the simple closed curve. Simple closed curve, can write down simple closed curve C, okay, simple closed curve C, except at finite number of points. There are few points at which the function is not analytic, but those points are finite. Okay, in that case, the integral value of that function, integral over C f of z dz, will be equal to 2 pi I into sum of the residues at its poles. Sum of the residues at its poles. What are z1, z2, z3? z1, z2, and z3 are poles. So sum of the residues at the poles. We can even rewrite this as, that is, implies integral over C 0 to closed integral f of z dz will be equal to 2 pi I into sum of the residues at its poles. At its poles. You can make a note here itself. If the poles lie on the real axis, if the pole lie on the real axis, it will be pi I into sum of the residues at its poles. So I'll write it off fully. Closed integral f of z dz will be equal to pi I into sum of the residues at its poles. If the poles lie on the real axis, it is only pi I ma. Just remember this. In general, it is 2 pi I into sum of the residues at its poles. So we'll do problems. Anyone has any doubts in the definition? It is finite number of residues. That also should remember. And you all know how to calculate residues. Already you have done residues, right? So you know how to calculate the residues. Okay, take down. Evaluate. integral over C, evaluate integral over C, e power z divided by z plus 1 the whole square into dz, e power 1, integral over C, e power z, z plus 1 the whole square into dz around the circle mod z minus 1 equal to 3. Around the circle mod z minus 1 is equals to 3. See, here no, generally it is given evaluate. So you can even use Cauchy residue theorem, or you can even use Cauchy integral formula for the derivatives also here, and you can evaluate it. Okay, so both the ways you can do, but now we are doing Cauchy residue theorem. So I'll be evaluating using Cauchy residue theorem. You can just write down here, what is your f of z? F of z is equals to e power z divided by z plus 1 the whole square. Now, can anyone tell me what are the poles here?
Z is equal to -1.
What is the order?
Order 2, ma'am.
Very good. Z is equal to -1 is a pole of order 2. Okay, Z is equals to -1 is a pole of order 2. Now, what is our aim? Our aim is to evaluate using Cauchy residue theorem. So to evaluate Cauchy residue theorem, we have to find the residues at its poles. So here we have only one pole, which is Z equal to -1 is a pole of order 2. So now what we will try to find the residue of the function f of z at z is equals to -1. It is a pole of order 2. So what it will be? 1 by 1 factorial into d by dz of limit, sorry, 1
Will come
factorial,
outside.
yeah, limit z tends to -1 d by dz of the pole. What is the pole here? -1 is the pole. So z plus 1 the whole square into f of z. So this will be equal to limit z tends to -1 d by dz of z plus 1 the whole square into f of z. What is your f of z? It is e power z divided by z plus 1 the whole square. It is e power z divided by z plus 1 the whole square. Now z plus 1 the whole square, z plus 1 the whole square will be getting cancelled. So when you differentiate this, you'll get limit z tends to 1. When you differentiate this, you'll get e power z. So apply the limit, you'll get e power -1. You'll get e power -1. So write down by Cauchy residue theorem. Okay, please write down the full form. Okay, for the first problem, we can write down the full form. Cauchy residue theorem, integral over C. What is the given integral? E power z divided by z plus 1 the whole square into dz. First of all, I didn't check the point. I wrote it Numa. Here z is equals to -1 is a pole of order 2. I should check whether it is lying in this region. Okay, so what is this? It is a circle x plus iy minus 1 is equals to 3. So it is a circle with a center 1 comma
So 0.
1 comma 0. Okay, 1 comma 0 and the radius 3. Okay, so here 1 comma 0. So surely -1 will write. Z is equals to -1 lies inside the region mod z minus 1 equal to 3. You should write down immediately there itself. Here z is equals to -1 lies inside the region mod z minus 1 equal to 3. So we are applying the Cauchy residue theorem. What does the Cauchy residue theorem says? This is equals to 2 pi I into sum of the residues at its poles. Okay, here we have only one pole, 2 pi I. So what is the other, only one pole? The value of the pole we got it is e power -1. E power -1. That's all. That is your answer. 2 pi I by e. You all understood?
Ma'am, here z equals -1 is on the real line, right?
That is equals to -1.
It will lie on the real axis.
No. 0 comma -1, where it will lie?
It will be -1, comma 0, right?
Oh, sorry, -1 comma 0. So -1 comma 0, and which is the center here, dear?
Center is 1, comma 0.
Center is 1 comma 0, and here the pole is -1, right? Yeah. So -1 poles lie on the real axis. Okay. Okay, I missed one more term here. Actually, of an intended contour will be like this. Okay, better I will give off this term again after taking this. 1 minute, wait. Let me, I mean, if I can give the definition of that, I'll give it off here itself. The region will contain the real axis, ma. That is the meaning. Okay, better you don't take it now. I'll just erase it off. Why I'll tell you, because you will have a confusion here. Thus, that talking about the sum of the residues in pi I, the region will be like this, or region can be like this. You understand? The real axis, the region will get. It will not be contained like this. It will not be contained like this. Okay, you will have a boundary. You will have poles here. In that case, only it is pi I into sum of the residues at its poles, only for that case. But when the pole is inside the region, we are not bothered about it is on the real axis or not. The real axis itself will be the region for that. In that case, only it is pi I into sum of the residues. Is it clear? I'll again give it to you when we are talking about that problem. Now, if you take no, you'll get confused. Better I'll give it later part. Now you understand?
Ma'am, so the boundary of the
Yes.
curve should be the real axis.
Yes, the boundary of the curl will be the real axis. The later part we will study even the problems like that. In that case, we will have pi I into sum of the residues.
Okay.
Here you will get confused if I give that statement. The boundary will be containing the real lengths. In case only you can have that. Sorry, I shouldn't have given here, right? Fine. Take down next one. Evaluate. We'll do little complicated one. Evaluate integral over C. Evaluate integral over C z square minus 2z integral over C z square minus 2z divided by z plus 1 the whole square into z square plus 4 into dz. Evaluate z square minus 2z divided by z plus 1 the whole square into z square plus 4 into dz, where C is the circle, mod z is equals to 3. Where C is the circle, mod z is equals to 3 using Cauchy residue theorem. Using Cauchy residue theorem. Using Cauchy residue theorem. Okay, again write down here f of z is equals to z square minus 2z divided by z plus 1 the whole square into z square plus 4. Here z is equals to, see, equate the denominators to 0. So we'll get z is equals to minus 1 is a
Order
pole of order 2.
Yes,
And
ma'am.
what about here? Again, z is equals to, here you'll get z square plus
Y.
4 equal to 0. Z square is equals to minus 4. So plus or minus 2y. So z plus or minus 2y are poles of order
One.
1. Okay, either you can write it as a simple pole. You can even write it as a simple pole. Okay. Now, first of all, we will check which are the poles lying inside the region, which are the poles lying outside the region. Here, what is the given region? Mod z is equals to 3. So mod z is equals to 3 means circle with the center 0 and the radius 3. So z is equals to minus 1, sure we'll write. Z is equals to plus or minus 2 will also lie inside or not?
Yes, ma'am. Let it lie
Yes.
inside.
Both will lie inside. Here, z is equals to, what are the poles we have got? Minus 1, comma, plus or minus 2y. All lies inside mod z is equals to 3. So therefore, we will try to find residue at each of the poles. So residue of the function f of z at z is equals to minus 1. So minus 1 is a pole of order 2. So we will get 1 by 1 factorial limit z tends to minus 1 d by dz of limit, sorry, d by dz of z plus 1 whole power 2, whole of order 2, right? So z plus 1 whole power 2 into f of z. What is your f of z? Shall I write it directly? Your f of z is z square minus 2z divided by z plus 1 the whole square into z square plus 4. Okay, 1 minute, wait, the charge is getting out. So what we have here is, yeah, now we'll simplify this. So this z plus 1 the whole square, z plus 1 the whole square will be getting cancelled. Now 1 by 1 factorial will be 1. So limit z tends to minus 1, d by dz of what we'll have, z square minus 2z divided by z square plus 4. Come on, differentiate this. Once you differentiate this, you will get z square plus 4 into differentiation of the numerator, which will be 2z minus 2. 2z minus 2. Then minus of the numerator. Numerator is z square minus 2z. Z square minus 2z into differentiation of the denominator, which is 2z. Which is 2z divided by what we have, z square plus 4. The whole square. Outside you have limit z tends to minus 1. Z tends to minus 1. Is it clear? Okay. Now we will simplify this. We'll simplify this. So you can apply z tends to minus 1. So once you apply z tends to minus 1, what will happen? You will get minus 1 the whole square. So minus 1 the whole square plus 4, which will become 5. So here minus 2 minus 2 will become minus 4 minus z square will become 1. Minus of minus, this will become 2. And here it will become minus 2 divided by z square plus 1 the whole square. So 5 the whole square. Simplify this, minus 20 plus 3 2s are 6, right? 6 divided by 25. So minus 14 by 25. So we are getting the value of the residue at z is equals to minus 1. The value of the residue at z is equals to minus 1 is minus 14 by 25. You all understood here? Okay, come for the next part. What is the next part? So next part is we have to find residue of the function f of z at z is equals to plus or minus 2i we have. So we will take plus 2i. So plus 2i I'll take. Okay, it is a pole of order 1. It is a simple pole. So simple pole means limit z tends to 2i. So we'll get z minus 2i into f of z. What is my f of z, ma? F of z is z square minus 2z. Z square minus 2z divided by z plus 1 the whole square. Z square plus 4 can be written as z plus 2i into z minus 2i. You can write this as z plus 2i into z minus 2i. So z minus 2i, z minus 2i will be getting cancelled. So we'll get limit z tends to 2i. Okay, limit z tends to 2i, z square minus 2z divided by z plus 1 the whole square into z plus 2i. Now substitute the limit. So we'll get 2i the whole square. So 4, I square will give you minus 1. So this will become minus 4. Minus 2 into minus 2i. So this will become minus 4i divided by 2i plus 1 the whole square. Okay. So we'll get 2i plus 1 the whole square into 2i plus 2i will become 4i. 2i plus 2i will become 4i. Simplify this. You can take minus 4 commonly outside. You will get 1 plus I. Okay, 1 plus I divided by 2i plus 1 the whole square into 4i. So 4 and 4 will be getting cancelled. You can simplify this. You can simplify the denominator. Once you simplify, you will get 1 plus I divided by 2i plus 1 the whole square. So a square will become minus 4. Minus 4 plus 2ab. So this will become 4i plus 4i, then plus 4. Sorry, plus 1. Plus 1 into I. into I. So once you simplify this, you'll get 1 plus I divided by 4I plus 3 or 3 plus 4I. It is 3 plus 4I. So you can multiply the I inside. So once you multiply the I inside, 1 plus I, you'll get 3I minus 4. Is it clear? Similarly, you have to find the residue of the function f of z at z is equals to.
Can you back one slide? No,
Earlier.
the one after this. That'd be -3, 4i -3
Where, dear?
inside the bracket.
Okay, -3.
Denominator.
Correct. -3 only. So I'll get -4 minus 3i, correct?
And ma'am, I think you missed a minus in the previous part.
Yes, on the numerator.
Where, dear? Okay, one minus sign is also there. Okay, fine. No issues. We'll bring the minus here. We'll have the minus here. We'll make it plus here. Okay.
It will become 1 plus I upon 3I minus 4.
Yeah. 1 plus I divided by -3. You'll get. I get -3I minus 4 I will get. So 1 minus sign. Yeah. So I'll get 1 plus I divided by 4 plus 3I. Correct?
Yes.
Yes or no?
Yes, ma'am. And we can
Yes, ma'am.
simplify this. 7
You
plus I
no
by
need to
20.
simplify. If it is needed, we will simplify. If it is needed, we'll simplify. Why I am saying not to simplify? Because see, here you're getting it as 14 by 25. Here you're getting it as sum with I. So you cannot add all these things. So you can just leave it as such. No need to bother about it. Okay. So then residue of the function f of z at z is equals to what we did? Minus 2i plus 2i we did. So we'll do minus 2i. So minus 2i will be equal to, it is a pole of order 1. So we'll have limit z tends to minus 2i z plus 2i into f of z. What is your f of z? Z square plus z, right? Yeah, z square minus 2z divided by z plus 1 the whole square into z plus 2i into z minus 2i. So z plus 2i, z plus 2i will be getting cancelled. I'll apply directly here. Minus 2i if I apply. So minus 2i the whole square will give you minus 4. Correct? Minus 4. So minus 2i minus 2 will give you plus 4i divided by, you have z plus 1 the whole square. So you'll get minus 2i. So 1 minus 2i the whole square, correct? 1 minus 2i the whole square into minus 2i will become minus 4i. So what will happen here? You can take minus 4 outside or you can take plus 4 outside. You can write it as I minus 1 divided by, expand this, a square minus 2ab plus b square. What will be plus b square, ma? Minus 4. Is it clear? Into minus 4i you have. So 4 and 4 will be getting cancelled. So you'll get I minus 1 divided by minus 3 minus 4i into minus I. So multiply that. So you'll get I minus 1. When you multiply by minus I, this will become plus 3i. Plus 3i. Here minus of minus, this will become plus. I square will give you 1 minus. So you'll get minus 4. I plus 1 by 4 plus 3i. Here we are getting 1 minus I by 3i minus 4. Okay. Okay, now you have to write it by Cauchy residue theorem, integral over C, z square minus 2z divided by z plus 1 the whole square into z square plus 4 is equals to 2 pi I into sum of the residues at its poles. Okay, so 2 pi I into, what are the sum of the residues here? Minus 14 by 25 What was the second one? Second one is 1 plus I divided by 4 plus 3I plus 1 plus I divided by 4 plus 3I. The last one is, I will write it as 1 minus I by 4 minus 3I. Shall I do it? I'll write it as 1 minus I by 4 minus 3. I'm taking 1 minus sign from both numerator and denominator. 1 minus I divided by 4 minus 3I plus 1 minus I divided by 4 minus 3I. That's all. You cannot simplify more than this. Is it clear? What, ma?
Yes, ma'am.
Okay. Next one you can take down.
Ma'am,
Evaluate.
could you show the residue of 2i and minus 2i once again? Okay, ma'am.
Okay. I forgot to ask you one thing. Ma'am, I have changed that question in the CAT paper. Those who have got 4, wherever was applicable, I have given 5. I hope you have checked it.
Yes, ma'am.
And for few students, the
ma'am.
marks were not got updated. I think everything would have got updated. Check it out. Because after this today, I cannot do anything. It will get freezed by today. Okay. Take down, evaluate. Evaluate integral over C, z minus 2 divided by z square minus z into dz, where C is the circle. Why do I take circle again? So, okay, you can do this. Where C is the circle, where C is a circle, x square plus y square equal to 4 using Cauchy residue theorem. Using Cauchy residue theorem. Tell me what are the poles here? What is your f of z?
Z is equal to 0 and Z is equal to 1.
Very good. Z is equals to 0 and Z is equals to 1. So the poles are Z is equals to 0 and Z is equals to 1. What are the poles? Order?
Both are 1.
Yeah, these are the poles of order 1. Come on, find out the residues and give it to me.
From 2 and minus.
Poles, what are the answers? Residue? Residue at Z is equals to 0 is 1. Nah? Okay. No, 2.
No, it's 2, ma'am.
Yeah, residue of f of z at Z is equals to 0 is 2. Good. Residue of f of z at Z is equals to 1 is minus 1.
Minus 1.
Now find out the integral value. So it will be 2 pi into sum of the residues. Sum of the residues is 2 minus 1, which is 1, which will be equal to 2
Pi,
pi.
ma'am.
2 pi I, right?
Yes, ma'am.
2 pi I. Okay. Next one we will do a different problem. Evaluate integral over C. Evaluate integral over C. Z secant Z. Z secant Z divided by 1 minus Z square into dz. Evaluate integral over C. Z secant Z divided by 1 minus Z square dz, where C is the ellipse. Where C is the ellipse, x square plus 9y square is equals to 9. C is the ellipse, 4x square plus 9y square equal to 9. Okay. So given is ellipse, first we'll simplify the ellipse so that we'll see the curve. So 4x square plus 9y square equal to 9. So divided by 9, you will get 4x square plus 9y square is equals to 1. So 4 by 9, 9 by 9 you'll get. So you'll get x square by 9 by 4 plus y square by 1 equal to 1. So what is the major axis and where is the minor axis here? What is the major axis of the ellipse? What is the minor axis of the ellipse? By 2.
Major axis is 3 by 2. X
Now
equal
this is
to
your standard equation of your ellipse, right? X square by a square plus y square by b square equal to 1. Now what is the value of a here? A is equals to 3 by 2 and b is equals to 1.
1.
So the major axis is cutting the ellipse at 1.5 comma 1.5. Correct? 1 by 2, right? 1.5 and the minor axis at 1. 1 comma minus 1. This is 1.5 and this is minus 1.5 and this is 1 comma minus 1. Is it clear? Okay. Now this is your region. This is over. Okay. Now what is your f of z? Let f of z is equals to, what is your f of z, ma? Z secant z divided by 1 minus z square. You can rewrite this as z by 1 minus z square into secant z can be written as 1 by cos z. Yeah, 1 by cos z. Now this is of the form z by 1 minus z into 1 plus z into cos z. Now what are the poles? Here z is equals to, what are the poles? Z is
1
equals
and
to 1
minus.
comma minus 1 are simple poles. Other than that, cos z is also one pole, no? Whenever you have cos z, what will be the value of z?
And then pi by 2.
Only n pi by 2 or all the other values? You can write it as 2n plus 1 into pi by. We did already one problem like this. So z is equals to 2n plus 1 pi by 2 or poles of order 1. Everything is of order 1. Now we will check which are the poles are lying inside, which are the poles are lying outside. So here z is equals to 1 and minus 1 will lie surely inside. Minus 1 and 1. Okay. Surely lie inside. Okay. So z is equals to plus or minus 1 lies inside the ellipse. What's the ellipse given, ma? Write on the ellipse. Ellipse 4x square plus 9y square is equals to 9. Now we will check this value. Put n is equals to 0. When you put n is equals to 0, it is pi by 2. Pi by 2 is 3.14. 3.14 by 2. That's 3.14 by 2, ma. Just check and tell me what is the value of 3.14 by 2.
And 1.57.
1.57. Listen. So when I put n is equals to 0, I'll get pi by 2. When I put n is equals to 1, what I will get? 3 pi by 2 plus or minus 5 pi by 2 and so on. Okay. So I'm getting plus or minus 1.57 plus or minus, this will be surely 3 times of this 1.57, right?
Yes.
3. What's the value? Can anyone tell me the value? 3 into 1.57. Just multiply and tell me.
4.7.
Okay, 4.72 and plus etc. Now check it out whether this 1.57 will lie inside.
No, ma'am, it won't.
It won't, because we have the major axis cutting at minus 1.5 and 1.5. We have 1.57. So 1.57 will lie outside. So here, what is that term? Z is equals to 2n plus 1 into pi by 2 lies outside the ellipse 4x square plus 9y square equal to 9. So what we should find? We should find the residues. We have to find the residues only at the point where the poles lies. So we have to find residues of f of z at z is equals to 1 and residue of f of z at z is equals to minus 1. Come on, can anyone find out at z is equals to 1 and tell it to me? Z is equals to 1 will be, it is a pole of simple, one first order. So Z tends to 1. We have limit, Z minus 1 into f of z. What is my f of z? Write down the f of z. F of z is z divided by, z divided by 1 minus z into 1 plus z into cos z. Okay. Correct? What I'm writing
Yes, ma'am.
is, yeah, z divided by 1 plus z divided by 1 minus z into cos z. Now, if you simplify this, you will get minus z. This and this will be getting cancelled with one minus sign. So I'm taking that minus sign here. Okay, divided by 1 plus z into cos z. Limit is from z tends to 1. Now apply the limit minus 1 by 2 cos 1. Minus 1 by 2 cos 1. Okay, that's it, over. Then find out residue of the function f of z at z is equals to minus 1. So this will be limit z tends to minus 1, z plus 1 into f of z. F of z is again z divided by 1 minus z into 1 plus z into cos z. So again plus 1 plus z and 1 plus z will be getting cancelled. When you apply minus 1, you will get minus 1 by minus 1, minus of minus, it will become plus 1. So 2 into cos of minus 1. What is cos of minus theta?
Cos theta, ma'am.
Cos theta. So cos 1. So therefore, by Cauchy residue theorem, you can even write down for your reference. One problem, we'll write it clearly. F of z at z is equals to cos z is 0 because the point lies outside. Okay. So by Cauchy residue theorem, integral over C, what is the question we have? Z secant z divided by 1 minus z square into dz will be equal to 2 pi I into sum of the residues at its poles. This will be equal to 2 pi I into, what are the residues we have? Minus 1 by 2 cos 1, minus 1 by 2 cos 1 and minus 1 by 2 cos 1. Again, second one is also minus 1 by 2 cos 1, no? Both. Okay. Minus 1 by 2 cos 1. So this will be equal to 2 pi I into minus 2 times 1 by 2 cos 1. So minus 2 will be getting cancelled. You will get minus 2 pi I by cos 1. Minus 2 pi I by cos 1. You can even write it as minus 2 pi I secant 1 because that was given in the question. Is it clear?
Yes, ma'am.
We'll wind up the class here. So other things we'll see it in the next class. Is it clear?
Yes, ma'am.
Take the attendance, then you can leave.